In this video, we are going to see six different functions which are going to be used for coupon days calculations for a bond. So if you are trading a bond today, or if you are doing a valuation of a bond today, if you're calculating the mark to market of a bond today, these six days related parameters are very, very important. One of them is that what was the previous coupon date? When was the last coupon paid for this particular bond? When will the next coupon be paid? Now, days between previous coupon date and the next coupon date are very important for calculations of the value, the amount of the interest that you're going to get on the next coupon date. For that, we will need number of days between previous coupon date and next coupon date. How many number of coupons are still pending? How many number of days are there between previous coupon date and settlement date? Now, in the language of bond mathematics, this number of days between previous coupon date and the settlement date is called as broken period. Because on the basis of this, you calculate accrued interest. And this accrued interest is to be paid to the seller, which means in the clean price of the bond, this accrued interest is added. And for that, you need to calculate broken period, which is nothing but number of days between the previous coupon date and the settlement date. And how many number of days are there between the settlement date and the next coupon date? So if you're trading a bond today, then from today till the next coupon date, how many days are there, so that you get to know that what is the proportion of the buyer's interest in the entire coupon. Now, before we see these functions, two points that we need to understand and remember. First point is that these coupon functions are only relevant for the coupon bearing bonds. Obviously, zero coupon bonds do not pay the coupon, they do not pay the interest, and that's why these are not relevant for the zero coupon bonds. The second point is that these are relevant for only plain vanilla bonds. These are not relevant for amortizing bonds, or these are not relevant for staggered bonds, which means that if any amortization of the payments are happening in between, if there are any additional coupons are being paid in between, then probably these functions will not work. And most important thing is that this bond do not work with the last odd period, because the calculations are done in a way that it takes the maturity date and then does the back calculation for other days. So just to give you an idea, what do we mean by odd periods? If it is an odd first period, then what will happen, that the first coupon is an odd coupon, and after that you get periodical regularity. For example, in this case, 1st January 23 is an issue date, 31st March 2023 is the first coupon payment date, and after that every 6 months the coupon is being paid, which means that the first coupon is just 3 months, it's not 6 months. So the first period is an odd period. Similarly, in the last odd period, the last period is just different than the regular coupon payments. So regular coupon payments starting from the 1st January is every 6 months, while the last payment period is just 3 months. So for the first odd period, it's okay. These functions do not make much of a difference because it doesn't take the issue date into consideration. It is calculated from the settlement date and the maturity date. However, if there is an odd last period, then these functions will not be useful, because the functions are such that it first takes the maturity date and then does the calculation on a backward basis. So with these two things in mind, let's start doing the calculations and let's try to find out what are the different days and the dates for the coupon payments. So I have taken here three examples. One is the government security, Indian government security, and two are the Indian corporate bonds. The first bond is a semi-annual bond. In India, all the government securities do pay the coupon or do pay the interest on a semi-annual basis. And all the GSEC that I have seen at this point of time, all of them are 100 rupee face value. However, the corporate bonds may have a face value which is other than 100 rupee. It could be 100, it could be 1000, it could be 5000. Commercial papers are even 5 lakhs rupees. So, for the corporate bonds, the frequency is decided by the issuer, the frequency is decided by the corporate. We have been given the maturity date, coupon payments. So, when the coupon payments will be, the settlement date, and very, very important, what is the day count convention that these bonds are using for payment of the interest, payment of the coupons. In India, all the government securities do pay the interest on the 30 by 360 European basis. So 30 by 360 day count convention. Corporate bonds, some of them I have seen on the actual by actual basis, some of them are actual by 365. So you need to see the contract of this bond, you need to see the features of the bond, whether they are paying actual by 365 or actual by actual. Most recent bonds that I've seen, majority of them do pay the coupon based on actual by 365. So let's see these functions and let's find out the dates and the days. The first function is coup PCD. You don't even need to remember, it's intuitive. PCD means previous coupon date. So if I say coup PCD, the settlement date is today, which is 10th September 2023. Please remember, all these calculations are as on the settlement date. As on the settlement date. In our example, the settlement date is 10th September 2023. The maturity date is 14th January 2029 in this case. Frequency is semi-annual. So for the second bond, it will become annual. And the basis. I'll just do one thing. I'll just link the basis at the bottom here. At this point of time, it is blank, but we'll put some number over there. So what do you mean by basis? Basis is the day count convention. For 30 by 360 European, the basis will be 4. For actual by 365, it will be 3. For actual by 360, it will be 2. Actual by actual 1. And 30 by 360, US basis 0. So because government securities do pay 30 by 360, so the basis will be 4. For corporate bonds, actual by actual, as we have just seen, the basis will be 1. And actual by 365, the basis will be 3. Okay. Now I'm going to copy this in the next two rows, next two columns. So 14th July was the previous coupon date. 11th January 2023 was the, because this is annual, so the next will be 11th January 24. 6th August 2023 was the previous coupon date. Coup NCD, this is giving you the next coupon date. So settlement date, maturity date. The functions are very, very simple. You don't even need to remember a lot of things. Okay, frequency and then the basis. Basis means day count convention. So this is giving us the next coupon days. How many number of coupons? So coup num. Okay, again this is asking for settlement date, maturity date, frequency and basis. As you can see that it is asking almost similar parameters, similar inputs. Okay, you don't need to remember a lot of things while using these functions. Hoop days. Now, one thing to remember that though it is asking for a settlement date, the input is a settlement date. The calculation is done in a way that it does the calculation from the previous coupon date till the next coupon date. So, based on the settlement date and the maturity date, in the back end, the Excel does the calculation. Excel finds out that what is the previous coupon date, what is the next coupon date, and then does the calculation for you. So the settlement date is 10th September, maturity is 14th January, frequency is semi-annual, and in this case the basis is 4. Now, as you can see, it has asked for settlement date and maturity date in inputs. However, it has calculated the number of days between 14th July 2023 to 14th January 2024, which is 180 days as per 30 by 360 European measure. So 6 months, 180 days. However, in this case, it is 365 days. This is annual, so 1 year, and this is 6 months. So 365 divided by 2, so 182.5. Let's find out the broken period, which will be based on the coup day BS. I remember BS as before settlement, which means that the days from previous coupon date to the settlement date. So, coup days, not days, but day BS. Okay, settlement date, maturity date, frequency 2, and basis is 4. Again, this is calculating the number of days before the settlement date, which means previous coupon date to settlement date, 56 days. Now, for this particular period, the seller will receive the interest, which means that the accrued interest in the bond will be calculated for this many number of days. And coup days for buyer, coupon days for buyer, coup day from the settlement date to the next coupon date. So S and C, I remember it like this, S and C. It is easy to remember. Okay. Settlement date, maturity date, frequency, and the basis. Okay, so basis is 4 in this case, 124, which means that out of this 180 days, 56 days is for seller and 124 days is for buyer. If we just do 56 divided by 180, which means 31% of the coupon will be paid to the buyer and remaining to the seller. Okay, and 69% will go to the buyer. And similarly, out of 365 days, 242 is for seller, 123 is for buyer. Now, you may find in some cases that it's not matching with the total 365 days. That's because it may have a leap year into it. The calculations may have a leap year into it. So 66% is for seller, and remaining 34% is for buyer. The same way in this case, 19% is for seller and the remaining for the buyer. So these are the six functions. Many of the people don't know this function, and that's why they do all of these calculations manually. However, if in your portfolio the bonds are of plain vanilla nature, the plain vanilla bonds, whether corporate bond or whether a government security, there, or a municipal bond or a state government bond, any bond that you are having, and if it is a plain vanilla bond, then these functions can be useful. I hope you have liked this video. So thank you so much. If you have any further questions, if you would want me to make the videos on any other topics which is relevant, please put your comments in the comment box, and I'll try to create a video on that basis. Thank you.